Hello, I'm making this short video on, I believe it's called the Whitworth free plate method of creating flat surfaces via abrasion. So, if you have a rock which is mostly flat, and you take another rock which is also mostly flat, if you place these mostly flat surfaces together and rub them together, the two surfaces will erode the high spots between the two and create two flatter surfaces. But in this case, with two surfaces, we're really creating two smoother surfaces, where in this case, we may be imparting some force on these stones such that we will be creating a concave matched with a convex shape, or we'll be creating a convex shape with a concave shape to match. But here's the thing. If we include a third mostly flat rock into this process, and we mix it up where we use one and then another on the same initial stone, the only surface that relates this middle stone to these two stones, where all three of them relate to each other, is and only is a flat plane. So, up in Connecticut or on vacation, I procured these stones and knapped them into roughly circular shapes. And then I chose the mostly flat surfaces, the more flat of the surfaces available of the two. So in this case, we have these super high spots, so I decided to use this smoother side. On this side, we also have these high spots. Now, realize this, that these high spots, both of these rocks were pretty much the same on the other side as well. They looked about like this when they started. It just happened to be that these sides were a little bit better than these sides. And so then, what I ended up doing is, well, I did the free plate method of creating a flat surface. I would rub these stones together in mostly a circular pattern, mixing it up, just getting them abrading together. I did this with the added water to help with the process. And so, over the course of just a few hours, just a little bit of mindless activity, great for the thinking, you can end up getting these really, really flat stones. And now, it's really interesting, is that you can't quite tell on the camera how smooth and flat these surfaces are, but I can show you with the physics. These stones slide on each other like, I don't even know, like oiled pieces of flat metal. They're incredibly, incredibly smooth. They fall off of each other so easily, it's insane. It's very hard to keep this set of stones together without interlaying them in a non-flat orientation. If I put them on flat, they slide off of each other very easily. And so what's the purpose of this? Well, this is how we can create, I'll use this one as the most flat with the least low spots that happen of the two. I think this is because this is more of a sandstone, with these ones being the harder of the two. This one eroded quickest. And so with this very, very, very flat surface, we can begin to take measurements from it. So we can check to see if, say, something we've made me try to find something, for example. Here we have a flat piece of float glass, I believe. I believe from the greenish tint that it's soda lime float glass. But we can tell by placing these two structures together, we can measure, in essence, the flatness of this glass plate. If we were to say, place this glass plate onto this surface, we can test to see if there's any spots along this plastic or this glass, in which case we can get a piece of paper underneath. And now if we know that this stone is flat in comparison to, any surface, if this is a flat surface, any ability for us to put this single piece of paper in here will show us that there is imperfections in this glass. And now, this glass is not a great example. I just grabbed something really quick, but it could be a ruler. Imagine the edge of a straight edge. We want to make sure that that edge of the straight edge is very flat, such that, well, it reads a straight edge. And so we can begin to take metrology measurements using just some stones. Thank you for watching this short little video I thought of making.